What's up, guys? Welcome back to another episode of IB Computer Science. And today we're gonna go through A1.4. And today we're gonna talk about what is a translation process of interpreters and compilers, and also we're gonna do an in-depth explanation of bytecode interpreters, JVM, and JIT. And hopefully you guys will know everything listed here in the end of the video. Alright, so what is translation? So think about this. Your computer only knows two things, 0 and 1. This is the only code your computer knows. But what uh, us developer we're familiar with is those higher programming language such as Python, Java, JavaScript. So we need something to translate the thing we know to what the computer know, and this process is called the translation. So so you can think of translation as translating higher or middle language, such as like Python, program language, assembly language, to machine code. All right. So what are the translation process of interpreters and compiler, and the comparison between two translation process? So there are two kind of translation. One is interpreters and another is compiler. So interpreters is let's say for example you have like a list of codes, and what interpreter do is it reads the list of code one line by one line and execute the code one line by one line. So it only goes and execute to the next line as it finished reading and executing the first line. And what is a compiler? So compiler, what it do is it read all the line of code and once, then execute it all in once. So some pros of the interpreters will be is reading executing code line by line, meaning that's like it's really good for debugging, and it runs immediately because as it finish reading a code, it's executing. So it's executing the line of code immediately. And compiler is like translating the entire higher level code into machine code in a single comprehensive process before the program execute. So yep. And here is a comparison between compiler and interpreters. So in error detection, interpreters are better in error detection because it's detected as code is executed line by line. So so like the developer can know exactly where uh, what is wrong in which line of code, while compiler it's reading all the code and execute all the code in the same time. So you only know your error as it execute all the code. And the translation time, so for compiler it's high initial translation time and result in like fast execution. And for interpreters it's immediate execution but a longer translation time overall compared to compilers. And portability, the compiler have a lower portability because each platform, like compiler is not like platform independent, and interpreters is have high portability because codes run on any platform with the appropriate interpreters. And compilers are really good for like those performance critical application and system software, while interpreters are more ideal for development and those debug sessions. So some important like general thing to know is compiler is good for quick execution, performance critical application, and compiler have slower build time but instant runtime. And for interpreters, it's have a quicker build time and slower runtime, and it's more ideal for debugging section. Yep. All right. Here's the hard part. Let's talk about bytecode interpreters, JVM, and JIT. So previously we talk about compiler and interpreter, but compiler and interpreter they both have their pros and cons, and they are not like as like platform independent as like both of them are all not like that platform independent. So some genius made JVM. It stands for Java Virtual Machine. And inside Java Virtual Machine, there are some things such as like bytecode interpreters and like JIT. Is you can think of it as like a part of Java Virtual Machine. And what they do is they basically they transform any higher level code first to bytecode, then translate the bytecode to machine code, because like bytecode is a universal code, while like machine code is depends on like the OS system. So after it transformed like the higher level program language to bytecode, then like the bytecode could be used in, let's say for example, Windows, Mac OS, Linux, all of those. So here is a definition of bytecode interpreter. So like transferring higher level code to bytecode, then bytecode runs on a virtual machine or interpreters to machine code. This is like the whole process. And here, so JVM, we talk about JVM. It's a virtual machine that interprets a bytecode to whatever machine code your OS system is using. So you can think of like bytecode interpreter as like a part of JVM. And a really good analogy for like the how like the whole JVM works and like the purpose of turning high level code first to bytecode, then to the machine code is like, think of think of it as like the bytecode is at like a sheet of music. So this one is like universal, right? It's a sheet of music. But different people, for example, like violinist and pianist, they have their own system of like the music sheet. So what what so like transferring from bytecode to machine code is like transferring like the sheet of music to a specific sheet of music to violinist, and a specific sheet of music to pianist. So here is the whole process. First of all, the higher level code will compile to bytecode by compiler. Then bytecode then interprets to machine code by JVM's bytecode interpreter. And here is where the JIT, it stands for just in time, where it comes in. So like if JVM is constantly interprets the same bytecode to machine code, JVM will call like the JIT to replace the bytecode interpreter and let the JIT compile bytecode to machine code. Because like like bytecode interpreter is like interpreting, while like JIT is like compiling. So like JIT have like a faster execution time. So and the VM is stand for virtual machine. The VM in the JVM is the virtual machine where all these process happens. So here is like a more clear diagram. So at first, the high level language code will first compile to bytecode, but by a compiler. Then bytecode will then interpret it to machine code by a bytecode interpreter. Then if like the JVM realize that oh, like the bytecode is always like the same bytecode, or like this bytecode comes up a lot of time, then the JVM will cause the JIT to then compile the bytecode to machine code. But the front part of the chain is all like high level code compiled to bytecode by compiler. Then what's the difference? Like the difference is like if the bytecode didn't like what I said, if the bytecode didn't get like execute a lot of time, then it will still be interpreted by bytecode interpreter. But if the bytecode already been executed by a lot of time, then JVM will just directly call JIT just in time to come and compile the bytecode. So here are some more information, like a more detailed information and step by step of how everything's happened. And here are also like some more resource for you guys to understand if you want to have like a you guys want to have like a more comprehensive understanding of everything. And yeah, thank you. Bye bye.